All right, in this video, we're going to talk about suggested homework problems from 8.7. This is where we are doing integration by tables and other integration techniques, basically integration by tables here. We're not going to do reduction of order formulas here. We'll talk about that, I think, in differential equations. You might talk about that, but we're going to skip talking about reduction of order in this section. If you want to read up on it, you can do that. So let's go ahead and let's look at the first problem, which says that the integral of root 5 minus 9x squared over x squared dx. They want to know which formula from the table of integrals would you use to find the integral below. So let's look for one that involves something like a minus a u squared, or an a squared minus a u squared inside of a square root sign. And I've already done this, so I know I'm looking for table number 40 here. So we're going to use number 40, which says that root a squared minus u squared over u squared du is equal to negative root a squared minus u squared over u minus arc sine of u over a plus c. And we would just need to do a little fix here to make this 1/9 and 9, so that this 9x squared matches this 9x squared down here. U squared would be 9x squared, so u would be 3x, du would be 3dx, so I'd have a 3 and a 1/3 as a fixed 2, and my a squared would be 5, and my a would be equal to root 5. They tell me I don't think I need to actually finish this up, but since I did here, let's go ahead and show you. This would be 1/27 times the result of the formula here would be a negative root 5 minus 9x squared over 3x minus arc sine of 3x over root 5. And then we would have plus c, and I would probably bring that 1/27 in to make this 51x minus 1/27 arc sine of 3x over root 5 plus c. And we could have done that with trigonometric substitution probably. We just probably wouldn't have wanted to. When the table exists and we can just look up the form that involves a squared minus u squared on the table, and we just get to the final answer in terms of x, and we can just plug and chug like that as long as we have the right form. Why not use the table of integrals? So let's go ahead and let's look at 15. And it says that we have the integral of ln of x over 3 dx, and they want us to use the table of integrals first, and then they want us to solve by integration by parts and see that we get the same answer. So I'm going to be looking at table number 87. I'm just going to help you not have to hunt so much here because I've already done the hunting for you. So I'm using formula number 87. Formula number 87 says the integral of ln of u du is equal to u times 1 minus 1 negative 1 plus ln of u plus c. So u is equal to 1/3 x, du is 1/3 dx. I need 1/3 and I need 3. So this is going to be 3 times u is 1/3 x, negative 1 plus ln of x over 3 and then plus c is going to be x times -1 plus ln of x over 3 plus c will be a negative x plus x ln x over 3 plus c, or an x ln of x over 3 minus x plus c, one of those things there. Let's integrate by parts now. Integral of ln of x over 3 dx. U is ln of x over 3. dv is dx. So we have reciprocal of the argument times the derivative of the argument is going to be 1 over x dx. V is equal to x, so we have uv minus the integral of v du is equal to x ln of x over 3 minus integral of dx x ln of x over 3 minus x plus c, and we get the same answer both ways. All right, let's look now at number 17. Number 17 says the integral of 1 over x squared times x minus 1 dx. And using our table of integrals, we're going to use number 12. So let me get up here to number 12, right there. Formula number 12. Says integral of 1 over u squared a plus b u du is equal to -1 over a times 1 over u plus b over a ln absolute value of u over a plus b u, close parentheses, plus c. So let's see if I'm actually in that form. U is equal to x. Du is dx. That looks good. My coefficient b that's in front of x is 1. My real number a that is added to b x is -1. So a -1 over -1, 1 over x plus 1 over -1 ln of x over x minus 1 plus c is going to be a 1 over x minus ln of x over x minus 1 plus c. And we can make that into a ln of x minus 1 over x plus 1 over x plus c. And now we want to use partial fraction decomposition here. So 1 over x squared times x minus 1 is going to be equal to a over x plus b over x squared plus c over x minus 1. A x minus 1 plus b x minus 1 plus c x squared needs to be equal to 1. I have a x squared minus ax plus bx minus b plus c x squared equals 1. So my x squared terms are a plus c. My x terms are -a plus b. My constant term is a negative b. That equals to 1. So that gives me a plus c is 0. Negative a plus b is also 0. And negative b is equal to 1. So b is equal to negative 1. That makes negative a minus 1 equal to 0. Negative a is equal to 1. A is negative 1. That's negative 1 plus c is equal to 0. So c is equal to 1. So that gives me negative integral 1 over x dx minus integral 1 over x squared dx plus integral 1 over x minus 1 dx. So that's negative ln of the absolute value of x plus 1 over x plus ln of x minus 1 plus c. So this can be ln x minus 1 over x plus 1 over x plus c, and this answer and this answer are the same. So let's move on now to number 21. Instructions have changed, so we just find the indefinite integral here with the table of integrals. 2 over x cubed root x to the 4th minus 1 dx. And we're going to let u be equal to x squared. Du will be equal to 2x dx. So I need to multiply by x over x here. And this makes this 2x dx over x to the 4th root x to the 4th minus 1. So I'm in the form of du over u squared integral u squared minus a squared, where a squared is equal to 1, a is equal to 1. And we're going to use formula number 35, which matches this form right here. Formula number 35 says the integral of 1 over u squared root u squared plus or minus a squared du is equal to minus plus. So change the sign from what was there, root u squared plus or minus a squared over a squared u plus c. So let's plug and chug here. This is going to be negative root, and then keep this the same, x to the 4th minus 1 over a squared is 1. U is x squared plus c. So this was a minus. This changes to a plus. Again, if this says plus minus and it was a minus, we're going to change the sign here to the opposite of that sign. So this is going to be positive. All right, let's look at number 27. '27 says the integral of x over 1 minus secant of x squared dx. I think that u is probably x squared. Du is 2x dx, but I need a 2. And I need a 1/2. This would be 1/2 integral du over something minus secant u. And this could be a, it's just going to be a 1 in my formula, because my formula for Number 73 says, let me go to number 73. Integral 1 over 1 plus or minus secant u du is equal to u plus cotangent u, then minus plus, that means change the sign again, cosecant u plus c. So this is going to be equal to 1/2 of, and u is x squared, plus cotangent of x squared minus plus, that's a minus, that's going to change to a plus, cosecant of x squared plus c. And I'll just leave it just like that. I'll just change these brackets to parentheses here. I think that that's completely fine to leave it like that. Let's look at number 35. Says the integral of x over x squared minus 6x plus 10 quantity squared dx. So we're going to have to do some work to split this up into a couple different parts. First thing, I want to think about u is equal to x squared minus 6x plus 10, and du would be at 2x minus 6. First thing I want to do is 2 and 1/2 here. And then I want to do minus 6 and plus 6. I want to save this as 1/2 integral 2x minus 6 dx over x squared minus 6x plus 10 quantity squared. And then this 1/2 of 6 is going to be 3 integral of dx over x squared minus 6x plus 10 quantity squared. So I'm going to deal with that first integral first, and I'm going to write it as 1/2 integral of u to the negative second du. And then we've got all this that I'll deal with in a second. So I know you know how to deal with that power rule there, but that is formula number 1. No surprise that it's formula number 1 that says u to the n du is going to be u to the n plus 1 over n plus 1 plus c. So we'll have 1/2 of u to the negative first over negative 1. And I'll leave the plus c until I'm done completely. So this is going to be a negative 1/2. And then my u is in the denominator here, and my u is x squared minus 6x plus 10. All right. Now for the next part. So I am going to complete the square. And I have x minus 3 squared plus 1. And that's all squared in the denominator. And I have dx. So my u is equal to x minus 3. My du is dx. My a squared is 1, and my a is 1. And I didn't mark down what formula this is, but let me come and find it for you here. So there's some that involve u squared plus a squared. Let's go back up to, I think I went too far. Yes, here we go. U squared plus A squared right here. So I have U squared plus A squared right here to the N, and then du. So this is using number 25. Integral of 1 over A squared plus or minus U squared to the N. I don't think I have one that's specifically to the second. No, I don't. Du is equal to, and then 1, it's going to be a long one, and it's going to involve a different rule when I'm done. So 1 over 2 A squared N minus 1 times U over A squared plus or minus U squared to the N minus 1 plus 2N minus 3 integral 1 over A squared plus or minus U squared du, close bracket. So don't forget that we start off with a negative 1 over 2 x squared minus 6x plus 10 for our first part. And then we have plus 3. And then that's going to be over 2a squared, where a is 1 and n is 2. So 2 minus 1 is also 1. So this is going to be over 3 halves times u is x minus 3 over a squared plus u squared to the n minus 1 is going to be x squared minus 6x plus 10 to the first plus 2 times n minus 3. 2 times 2 is 4, minus 3 is 1, integral of 1 over, and then this is going to be x minus 3 squared plus 1 du. So this is negative 1 over 2 times x squared minus 6x plus 10 plus 3x minus 9 over 2 times x squared minus 6x plus 10 plus 3 halves integral 1 over x minus 3 squared plus 1 squared du. Add these parts that are alike here and make this 3x minus 10 over 2 times x squared minus 6x plus 10. And then this is a arctangent rule. I just need to find the formula number for that. So that is going to be number 23. So using formula number 23, which says the integral of 1 over a squared plus u squared du is equal to 1 over a arctangent of u over a plus c, then this is going to be 3x minus 10 over 2 times x squared minus 6x plus 10 plus 3 halves times 1 tangent of u, which is x minus 3 over 1 for A, plus C, and there it is. All right. Let's look at number 39. '39 says integral e to the 3x over 1 plus e to the x cubed dx. So my u has to be 1 plus e to the x. My du has to be e to the x dx. So this is e to the x dx, needs to sit up here as du. This is e to the 2x. This is 1 plus e to the x to the third. So I think that my u is actually e to the x here, and that this is u squared over, and then a plus bu to the third, and that is formula number 8 says that. So let's look at formula 8. And it says integral u squared over a plus bu cubed du is 1 over b cubed times 2a over a plus bu minus a squared over 2 times a plus bu quantity squared plus ln of a plus bu in absolute value bars, all that plus c. So my a is equal to 1, and my b is equal to 1. So this is 1 over 1 cubed is 1. 2a is 2 over 1 plus e to the x minus 1 over 2 times 1 plus e to the x quantity squared plus ln of 1 plus e to the x plus c. And 1 plus e to the x doesn't really need absolute value bars around it because it's always positive. So you can just put parentheses around that and be good. Let's go ahead and look at 45. Negative pi over 2 to pi over 2, cosine of x over 1 plus sine squared x dx. So that looks like I want u to be equal to sine x, du to be equal to cosine of x dx. And this would be in the form, I'll do the indefinite integral here of 1 plus u squared 1 du. Let's call this a squared, where a squared is 1, so a is 1. U squared is sine squared x, so u is sine x, and du is cosine of x dx. So using formula number 23, which says integral 1 over a squared plus u squared du is 1 over a arc tangent of u over a plus c. We have 1 over 1 is 1. So this will be equal to arc tangent of u is sine of x over a is 1, and I don't need plus c. That's what my indefinite would be. So this is my capital F of x, or my lowercase f of x here. I want f of pi over 2 minus f of negative pi over 2 for my definite integral. So I want arc tangent of sine of pi over 2 minus arc tangent of the sine of negative pi over 2 is arc tangent of 1 minus arc tangent of negative 1. Arc tangent of 1 is pi over 4 minus arc tangent of negative 1 is negative pi over 4. So that's pi over 4 plus pi over 4 is pi over 2. Let's look at our next problem is 63. Y equals x over root x plus 3, y equals 0, x equals 6. I'll sketch a little graph for you here that this is 6, 2. You can graph this on your graphing calculator. I just needed space to show you the table of integrals today and didn't show you my graphing calculator. So we need to integrate here. My area is going to be the integral from 0 to 6, x over root x plus 3 dx, and u will be equal to x, du will be dx. I'm going to have an a value of 3 and a b value of 1 for something that looks like integral of u du over root a plus bu. And this is going to be formula number 21, which is right there. And that equals to a negative 2, 2a minus bu over 3b squared root a plus bu plus c. So this is going to be the indefinite integral of x over root x plus 3 dx, which I'll call capital F of x, is equal to a negative 2, 2 times 3 minus b is 1 times u is x, root a plus bu, and then this is over 3b squared plus c is negative 2 times 6 minus x over 3 root x plus 3 plus c is going to be 2/3 x minus 6 root x plus 3 plus c, and I'll call that f of x, and I want f of 6 minus f of 0 for my definite interval. So when I stick 6 into 6 minus 6, that's going to be 0 times all the other stuff. When I stick 0 in, this is 2/3 of -6 root 3. So that's going to be positive 12 over 3 is 4 root 3. And that's approximately 6.928 square units. If you check that with your calculator. So let's finish up here with a couple more problems. We've got 69 and 71, I believe. So 69 says n is equal to 5,000 over 1 plus e to the 4.8 minus 1.9 t dt. We're on the interval from 0 to 2, and we want to find the average value of the function. So the average value, if you remember this formula, is equal to 1 over b minus a, integral a to b of the function here, 5,000 over 1 plus e to the 4.8 minus 1.9 t, and then dt. So this is going to be, pull the 5,000 out and divide by 2. It's going to make that 2,500 over, and then I need 0 to 2 here, 0 to 2. U is going to be 4.8 minus 1.9 t. So du is a negative 1.9 dt. So I need a negative 1.9 up here with dt and divide by a negative 1.9 down there. 1 plus e to the 4.8 minus 1.9 t. And that's going to let me use number 84. '84 says the integral of 1 over 1 plus e to the u du is u minus ln 1 plus e to the u plus c. So I have this multiplier of 2,500 over negative 1.9, and then times u, which is 4.8 minus 1.9 t minus ln of 1 plus e to the 4.8 minus 1.9 t plus c. That's my capital F of t there. And capital F of 2 minus capital F of 0 is going to be 2,500 over negative 1.9 times 4.8 minus 3.8 minus ln of 1 plus e to the 4.8 minus 3.8 minus 4.8 plus 0 plus ln of 1 plus e to the 4.8, all of that times this constant multiplier out here, so 4.8 minus 4.8 will go away, and we have 2500 over negative 1.9 times negative 3.8 minus ln of 1 plus e to the first plus ln of 1 plus e to the 4.8, and you can put that into your calculator at this point and get approximately 401.4. And 71 will be our last problem for this video. Y is equal to x root 16 minus x squared, y equals 0, x equals 0, x equals 4. So little sketch here that this would be something that swoops way down, swoops way up, and comes like this, and it goes through 0, 0. It goes from negative 4 to 4 here, but I'm only interested in this part of it from 0 to 4. And I want to revolve around the y-axis, so I think the shell method is best for me here. So this is going to be v is going to be 2 pi integral from 0 to 4 of, and then there will be a multiplier of x times this height, so that will be x squared root 16 minus x squared dx. And then I'm going to look for an appropriate formula. I'm going to tell you that I'm going to be using number 38, which says integral of u squared root a squared minus u squared du. And that is right there. And it's equal to 1/8 of u times 2u squared minus a squared root u squared minus a squared plus a to the 4th arc sine of u over a, all that plus c. So u is equal to x, du is dx, a squared is 16, a is 4. Don't forget you have the multiplier of 2 pi out front. So capital F of x is 2 pi times 1/8 times x times 2x squared minus 16 square root of, should say a squared minus u squared. 16 minus x squared plus a to the 4th, so 256 arc sine of u over a is x over 4, and all that plus c. So we have pi over 4 times all this stuff. So let's find now f of 4 minus f of 0 is going to be pi over 4 times 4 times 32 minus 16 root 0. So all that's a 0 plus 256 arc sine of 1 minus, and that's all 0 because of that 0, plus 256 arc sine of 0. That's 0. So this is pi over 4 times 256 times pi over 2 is 256 pi squared over 8. 8 goes into 256 32 times, and my answer is 32 pi squared cubic units. I'm not sure on my area problem that I said square units, but I should have. And that's it for this video. We'll come back next time and talk about suggested homework problems from 8.8, which are improper integrals, probably the most important thing for you to know. I mean, you need to know all of these integration techniques before chapter 9, but you really need to know how to deal with improper integrals, which are going to be integrals that are undefined in the middle of their region because they have asymptotic behavior in the middle. So far, we've not dealt with anything where this integrand was undefined between A and B. We'll deal with that in 8.8. We'll also deal with integrals where one or both limits, either the lower bound or the upper bound or both, or are unbounded, with the lower bound being negative infinity, the upper bound being positive infinity, or both. That's really, really important for what we're going to be doing in chapter 9 with infinite series, because the infinite series and the integral with those limits are going to be related because of the idea of our Riemann sum that we talked about from chapter 4. So if you know how to find the integral and see if it's going to come out to, we call it converge to a value. Does it equal a number like this? This is a convergent integral. It converges to a value here. Then the infinite series in chapter 9 is going to converge. But if this integral comes out to be something that does not exist, infinity, negative infinity, there's just oscillating behavior and you can't figure it out, whatever it is, then the infinite series is going to not have, is going to be divergent, we call it. So if the integral diverges, the infinite series that's related to it will diverge. If the integral converges, the infinite series that's related to it converges. More on that in chapter 9. I'm sure none of that made any sense right now. Just understand that 8.8 is going to be a really, really, really important topic for you. There's some important theorems that are in there that you should look at for the, we'll talk about them next time. But there's you may not even be told to memorize them by your teacher, but look at all the theorems that are in 8.8 because they're going to show up in other forms in chapter 9. And the only way to prove those rules, if you're told to do a proof in chapter 9, is to go back to the theorems in 8.8 and write it as an integral. Okay, enough on that. We'll talk about 8.8 next time. See you for the next video.